Says that write down the molecular orbital configuration of the following species. The species given are nitrogen, N2 plus, N2 minus, and N2 2 minus. So we will be drawing the the molecular orbital configuration of such species. To calculate the bond order for nitrogen, bond order can be calculated easily. That is Nb minus Na divided by 2. You have the number of electrons in the bonding orbital, which is equal to 2, 2, 4, 5, 6, 7, 8, and 9, 10. And in the antibonding there are 2 and 2, 4. So it is equal to 10 minus 4 divided by 2, that is 6 by 2, which is equal to 3. So the bond order of N2 is also 3. Next we calculate or write down the molecular orbital configuration for N2 plus. So for N2 plus, we have to write a sigma 1s bonding, then sigma 2s bonding, sigma 1s antibonding, then comes a sigma 2s bonding, then sigma 2s antibonding, then comes pi y bonding is equal to pi z bonding, then comes sigma x bonding. Next you have pi star y equal to pi star z, and lastly you have sigma x star. Note one thing, in this particular configuration we have written, or we have thought of the x-axis to be the internuclear axis. So in N2 plus there are total 7 plus 7 minus 1, which is equal to 13 electrons to be distributed, if I am considering the whole molecule and not only the valence electrons. So if I am considering the whole molecules, there are 13 electrons to be distributed, and it is distributed as such. So you have 2, 2, 4, 5, 6, 7, 8, then 9, 10, 11 and 12. So that is, and 1 is left, that is 13. So one thing can be said that N2 plus is paramagnetic molecule. So N2 plus is paramagnetic molecule because of the unpaired electron that is present on the sigma x bonding orbital. We can also calculate the bond order for N2 plus. In calculation of the bond order for N2 plus, it is equal to Nb minus Na divided by 2. So number of electrons in the bonding orbital is 2, 2, 4, 5, 6, 7, 8 and 9. And there are 2 and 2, 4 electrons in the antibonding orbital. So they are equal to 9 minus 4 divided by 2, which is equal to 5 by 2. So the answer is equal to 2.5. So the bond order for N2 plus molecule is also equal to 2.5. Now kindly remember one thing, that the filling of these particular electrons in the molecular orbital takes place according to the Aufbau principle, the Hund's rule for maximum multiplicity, and also with the help of the Pauli's exclusion principle. And also in these filling we are considering the x-axis to be the internuclear axis. So after this we now draw the configuration for N2 minus molecule, or we write down the configuration for N2 minus. In N2 minus there are 7 plus 7 plus 1, that is 15 electrons to be distributed. Therefore we can say that the filling will start as follows. There is sigma 1 is bonding, then sigma 1s anti-bonding, then sigma 2s bonding, then we have sigma 2s anti-bonding, then we have pi bonding y equal to pi bonding z, then we have sigma x bonding, then we have pi anti-bonding y is equal to pi anti-bonding z, and lastly we have the sigma x anti-bonding. So if we start filling the 15 electrons that are present, it is 2, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 1 unpaired in the sigma anti-bonding y orbital. Hence we can say that N2 minus molecule, or N2 minus species rather, is a paramagnetic species. Paramagnetic species, why? Because of the presence of the unpaired electron on the pi star y or the pi anti-bonding y orbital. We can also calculate the bond order for N2 minus. So the bond order for N2 minus is calculated as NB minus NA divided by 2, or the number of electrons in the bonding orbital minus the number of electrons in the anti-bonding orbitals divided by 2. So number of electrons in the bonding is 2, 2, 4, 5, 6, 7, 8, 9, 10, and in the anti-bonding there is 2, 2, 4 and 5. So we can say the bond order is equal to 10 minus 5 divided by 2, which is equal to 5 by 2, which is equal to 2.5. So N2 minus species and N2 plus species has the same kind of bond order, and we can see that both of them have similar kind of bond strength. Next we draw the molecular configuration for N2 2 minus. So in N2 2 minus there are total of 7 plus 7 plus 2, that is 16 electrons to be distributed. So in a total of 16 electrons, it can be distributed as follows. We have sigma 1s bonding, then sigma 1s anti-bonding, sigma 2s bonding, sigma 2s anti-bonding. Then we have pi bonding y, which is equal to pi bonding z. Then we have sigma bonding x. Then pi y star equal to pi z star. And lastly we have sigma x star. Since total there are 16 electrons to be distributed, we can distribute them as follows: 2, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and we have 15 and 16. So this takes place because we are filling these electrons in the molecular orbital according to the Aufbau principle, the Hund's rule for maximum multiplicity, and the Pauli's exclusion principle. So on a whole we can say that N2 2 minus molecule is paramagnetic, Paramagnetic because of the presence of unpaired electron on pi star y and pi star z orbitals. Also the bond order for N to 2- is Nb minus Na divided by 2, which is equal to 2 to 4, 5, 6, 7, 8, 9, 10. So there are 10 electrons in the bonding orbital, and 2 to 4, 5 and 6 electrons in the anti-bonding orbital. Hence it is equal to 10 minus 6 divided by 2, which is equal to 4 by 2, which is equal to 2. So N to 2- has a bond order equal to 2. So according to the question which we are discussing, we have already discussed about N2, N2 plus, N2 minus, and also N to 2-.